Section 1.4b, don't stop when you are tired, stop when unknown. So in the last section, we learned about how to evaluate functions. So this is a continuation, but now we're going to be looking at something called the difference quotient. And the difference quotient will be used quite a bit when you move on to your calculus classes. And so here we're going to call this the expression f of x plus h minus f of x divided by h for h not equal to 0 is called the difference quotient of the function f. And so really, I'm going to label these as this little part here is going to be number 1. And then I'm going to use number 2 for f of x. And so we're going to do these problems in 3 steps. So the first step is for us to evaluate what f of x plus h is going to be. So first, let's write down the function. So this is step 1. So I have f of x is equal to 2x plus 1. So anywhere that I see an x, I'm going to replace it with x plus h. And so we simplify and we get f of x plus h is equal to 2x plus 2h plus 1. There's nothing else I can do to simplify this further. So for step 1, this is the answer that I get. And so now for step 2, we're going to figure out what f of x is. And so first I write down the function so that I can see what I'm working with. And so anywhere that I see an x, I'm going to replace it with whatever's in the parentheses, in this case x. And so if we simplify, we get f of x is equal to 2x plus 1. And then last, the step number 3 is we're going to take these 2 steps, step 1 and 2, and plug them in to the difference quotient. Okay, so for step 1, f of x plus h, we got 2x plus 2h plus 1, so I'm going to write that down. Let me just rewrite the difference quotient, and this is equal to, so f of x plus h, again, this is what we got for that, minus f of x. And for f of x, we got 2x plus 1. I'm going to go ahead and use parentheses since I'm subtracting the whole expression there. And then we're going to simplify. So I'm going to distribute the negative. And keep simplifying. So 2x minus 2x is 0. 1 minus 1 is 0. So we're only left with 2h divided by h. These cancel here or become 0. And now the h's can simplify. H divided by h is 1. So we end up with 2. So my answer is that the difference is 2. Okay, so let's try letter B. Okay, so for letter B, step 1. Step 1 is always the same, is to figure out what f of x plus h is. And so I'm going to go ahead and work this out by writing the equation. So anywhere that we see an x, we're going to replace it with x plus h. And then we want to simplify. So x plus h squared is the same as x plus h times x plus h. So x times x is x squared, x times h is xh, plus xh plus h squared. Simplify, or let's distribute the 3. 3x squared plus 3xh plus 3xh plus 3h squared. Gather your like terms. 3xh and 3xh is 6xh plus 3h squared. So for f of x plus h, this is what we get. 2, find f of x. So anywhere we see an x, we're going to replace it with whatever is in the parentheses, in this case x. Simplify. So we get 3x squared. And then finally, step 3 is plug it into the difference quotient. So f of x plus h we found was 3x squared plus 6xh plus 3h squared minus f of x. F of x is just the original equation divided by h. Simplify. So 3x squared minus 3x squared will become 0. And then we get 6xh plus 3h squared divided by h. Notice in the numerator, there you have an h in common. So I can factor out an h, and I can factor out a 3 as well. So in order to get 6xh, I would have to have a 2, because 3 times 2 is 6. And then we have an x plus h. We can check 3h times 2x is 6xh, and 3h times h is 3h squared divided by h. The h's here will become 1. And so we're left with 3 2x plus h. And so my difference quotient is equal to h. Okay, so let's go on to the next example. So again, step 1, evaluate f of x plus h. So my function here is f of x equals x squared plus 2x minus 3. Anywhere you see an x, we're going to replace it with x plus h. And then we need to simplify. X plus h squared is the same as x plus h times x plus h. Plus, distribute the 2, we get 2x plus 2h minus 3. Earlier, we did x plus h times x plus h. You can see it in the above example. And so we get x squared plus xh plus xh plus h squared. So we're just multiplying. So gather your like terms. So we end up with x squared. Xh and xh is 2xh plus an h squared plus 2x plus 2h minus 3. So that's the first part of for letter C, and then the second part is to figure out f of x, which is going to be the same as the original equation. So f of x is always the original equation. And then step 3, we want to plug it in to our difference quotient. So for f of x plus h, this is what we got here, down here. So we got x squared plus 2xh plus h squared plus 2x plus 2h minus 3. And then we're going to have a minus, and I'm going to squeeze this in here. So minus parentheses, x squared plus 2x minus 3. Okay, so I apologize here for squeezing this in. So f of x is this part right here. And this is all divided by h. So I'm going to continue over here. So I'm going to rewrite it just so we can see it better. And we had minus, so I'm going to write it in here, x squared plus 2x minus 3, all divided by h. Simplify, distribute the negative. Negative negative is positive 3. Check to see if anything cancels, and we can see the x squared would cancel with negative x squared. They become 0. And negative 2x and 2x become 0. Negative 3 and 3 is 0. So all we have left in the numerator is 2xh plus h squared. And in the denominator, we have an h. So in the numerator, they have an h in common. We can factor out that h. And so the h's will become a 1, leaving us with 2x plus h. So our difference quotient is equal to 2x plus h. Let's go on to the next page, 22. So for page 22, we're looking at a new function. A function that is defined by 2 or more equations over a specified domain is called a piecewise defined function. So example 2, a cellular phone company offers the following plan. $20 per month by 60 minutes. Additional time costs 40 minutes, $40, 40 cents per minute. The plan can be represented mathematically by writing the total monthly cost C as a function of the number calling t, minutes t. So here, a piecewise function basically is a function that is broken up into pieces, and they give you these conditions. So this condition here, if your variable t, which is the number of minutes, falls between 0 and 60, then we're going to use this part of the equation. If the number of minutes is greater than 60, then we use the second equation. And so you can think of these as 2 parts. The first part is the first one, and then the second part is the second equation. So it says find and interpret each of the following. So C45, remember that the number inside here is representing t, which is the minutes. So 45, if t is 45, then we look at our condition here, and it says that we're going to use the first one if t is between 0 and 60, and 45 is between 0 and 60. So C of 45 is equal to the first one, which is just the number 20. And so it says to interpret this. So what we would say is if 45 minutes are used, the cost is $20. Okay. On the next one, t is equal to 60 minutes. And so that means we're still going to use the first equation since we have the less than or equal to. So C of 60 is still going to just be 20. And then the last one here, t is equal to 90. 90 is greater than 60. That means we have to use the second equation. So the second equation is CT of 20 plus 0.40 t minus 60. So here we know that t is 90. So here's t, so that's 90 minus 60. 90 minus 60 is 30. So c of 90 is equal to 20 plus 12, which would be 32. So the interpretation is if you use 90 minutes, then you will have to pay $32. So piecewise defined functions you can find in everyday situations. For example, electric bills, water bills, the more water you use, the more you're going to pay. If you go out of town and you never use your water, you're still going to have a bill to pay when you get back. And so those are examples of piecewise functions. Number 3, evaluate the function when x is equal to -2, 2, and 3. So again, we have to figure out which part of the function we're going to use. So if we look at x equals -2, let's call this 1 and 2. -2, is that less than 0 or is it greater than or equal to 0? So that's less than 0. So that means that we're going to use the first function. So anywhere you see an x, we plug in the -2. -2 squared is 4, plus 1 is 5. And then let's let x equals +2. So 2 is not less than 0, it's greater than 0. So that means we're going to use the second equation. So anywhere we see an x, we replace it with 2. So f of 2 is equal to 1. And then the third one is let x equals to 3. So 3 is greater than 0, so we're going to use the second equation. I replace x with 3. So we get 2. Example 4, a museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more. Write a function relating the number of people n to the cost c. So we're going to have the cost c, n is going to be our our x, which is the number of people. And so we want to come up with some equations here, and they tell us that this museum charges $5 per person. We know n is representing people. And that's going to be the charge if your group has 1 to 9 people. If it has 10 or more, then there's only going to be a flat fee of $50. So here for 50, it has to be greater than or equal to 10. And then for the first one, we said it has to be between 1 and 9. So n has to be greater than 1, but less than or equal to 9. And so this is an example of a piecewise function. To graph this functions, then we can do the following. We can apply what we learned in section 1.1. And so I'm going to graph the first function, f of x is equal to 3, and I'm going to use a table. Now in the first chapter, we said you can pick any value for x, and you still can. However, we have some restrictions. So we're going to use this first one whenever x is less than or equal to -1. So numbers that are less than or equal to -1 would be -3, -2, and -1. So if x is -3, we would plug it in for x, but then there's no x here. So this is telling us that f of x is always going to be 3. So my y value is always going to be 3. Now something important that we need to talk about first is if you have a greater than or a less than sign, we're going to use an open circle. If we have a less than or equal to, greater than or equal to, then we're going to use a closed dot. This represents that it's part of the graph. This is not part of the graph. So I'm going to graph this line. So we have -3 and +3, -2 and +3, and -1 and +3. So my line is going to be here, and I need to know which direction it's going to keep extending to. And so it's anything less than 1. So that means that it's going to to the left. Okay, so that's going to be our graph. The second equation is x minus 2. We build a table here, and this says that we're going to use anything greater than -1. So anything greater than -1 is 0, 1, and 2. If we plug in 0 for x, then we get -2. If we plug in 1 for x, we get -1. If we plug in 2, we get 0. Okay, so the other thing that I want to use though is, even though it doesn't say equal to, we're going to go ahead and use -1. And the reason for that is here we have 0 and -1. So any number greater than -1 is going to include all of these decimal points. So what we want to do is, since we can't really identify what these points are, if we put -1 and use an open circle, then we know that we're not including -1, but we are including everything close to it. So if I plug in -1 here, I'm going to end up with -3. So let's go ahead and plot this. So at -1, we get -3, 1, 2, 3. We know that -1 is not included, so I'm going to use an open circle. 0, -2 is right here, 1, -1, and 2 and 0. So I can plug in my line or connect my line. So again, the important thing here is that this dot has to be open, since the inequality doesn't have an equal sign. And also notice that this one is included. So this has to not be included in order for this to be a function. Okay. The last part of this section is domain. Domain is going to be important for the rest of the semester. And so here, the domain, again, is the largest set of real numbers for which the value of f of x is a real number. The domain is all the x values that are being used as part of the graph. The range is all the y values that are being used as part of the graph. And an open circle means that the x value is not part of the graph, and a closed circle means that it is part of the graph. So basically, what you want to think about is the domain is all the x's being used to make this graph. And then the range is all the y values that are being used to make up the graph. And another important thing is, if you have an open circle, we're going to use parentheses when we write domain. If you have a closed circle, we're going to use brackets. And so here, let's put arrows here to make sure this graph is continuing. And if we want to find the domain, we want to look at what are the x-axis, what are the x values that are being used. So for example, this x value, if I go up, I will find it on the graph. This x value, if I go up, it will be in this part of the graph. This one would be on part of the graph. If I use -6 and come down, it's going to be on the graph. So basically for domain, we're using all of these values for x. And so this is going to go on forever. So we say that the domain is -infinity to +infinity. You always want to write the smallest number first. Now for the range, it's all the y values. So you want to look at the y-axis. So if I pick this point here on the y-axis, notice that it is going to land on the graph. So no matter which one I pick, it's going to land. So for the range, you're looking at all the y-axis values that are being used. And in this case, it's -infinity to +infinity. So let's look at the next one, domain. What x values are being used? So again, if we look at all these x values, these are all being used. Number 2, if I go down, I never touch the graph. If I go up, I never touch the graph. So we can see that this graph is going from 1 and it's ending at -3. So again, you want to use the smallest value, in this case, -3. It has an open circle, that means we're going to use a parentheses. And then 1 is a closed circle, so we're going to use a bracket. And then the range we look at the smallest y value being used. -5, if I go across, I'm never going to touch the graph. But -4, notice that it touches the graph. It's a closed circle, so we use a bracket. And then the highest value is going to be 0. And although 0 is not included here, it is included over here. So we use a bracket. You're not always going to have a graph, so we need to find the domain algebraically. And so there's really 3 things to ask yourself. Does the equation have a fraction? Does the equation have a square root? And does it have a logarithm? If your answer to these 3 questions is no, then the domain is always -infinity to +infinity. If the answer to these 3 questions is yes, that means that there's some restrictions or some values that we have to remove from our domain. So the first one, find the domain of the function f of x equals x plus 3 and write in interval notation. So the first question is, do you see any fractions here? The answer is no. Do you see any square roots? The answer is no. Do you see anything with the word log in here, logarithms? The answer is no. Therefore, my domain will be -infinity to +infinity. You can also think about the graph. This graph is a line. And so if you notice, it's going to use all the x values. Okay, so let's go on to the next one. X squared minus 7x. Do you have a fraction? No. Do you have a square root? No. It has a square, but not a square root. Remember, the square root would be using this symbol. So no fraction, no square root, and no logarithms. So the domain, -infinity to +infinity. This graph is a parabola. And so a parabola uses all the x values here. Then the next one, find the domain. Do we have a fraction? Yes, we have a fraction. So what that means is that there are some restrictions. Okay, so I'm going to say here, there is a fraction. So some restrictions will apply. So to find those restrictions, the first thing we want to do is set the denominator equal to 0. So basically the restriction, if you have a fraction, is any number that gives you a 0 here. Why? Because we cannot divide by 0. So the denominator here is x, and I'm going to set it equal to 0. And so this answer that you get is not included in the domain. So if I had a number line here, then we can use everything except for 0. So the way we write our domain is it's going to go from -infinity, because I'm using all of these values, but then I'm going to get to 0. And I don't want to use 0, so I use this symbol. And then I'm going to continue with 0, and then I'm going to go all the way over here, so that's positive. To include both of these, we use the symbol U, which stands for union. And so my domain is going to be this right here. The next one, do I have a fraction? Yes. So automatically, there's a restriction. So to find the restriction, remember we set the denominator equal to 0. My denominator is x plus 2. And then we solve for x, or for the variable. So x would be -2. So this would be not included in domain. So my domain will go from -infinity all the way to -2. And then it's going to start at -2 and go to infinity. And we use the union sign to say it's both of these that make up the domain. And if you're looking at a number line, we're using everything here, but we're not using this -2. Okay, the next one, 11, find the domain of the function square root of x plus 3 and write in interval notation. Do we have a fraction? No. Do we have a square root? Yes. So there is some restrictions. So the restriction comes with numbers that will give you a negative in the square root, since we cannot take the square root of a negative number. So to find those restrictions, we set the radicate, which is the stuff inside the square root, to greater than or equal to 0. So my radicand here is x plus 3. I'm going to set it greater than or equal to 0. And then I'm going to solve for x. So x is greater than or equal to -3. So I basically subtracted 3 on both sides. Unlike the other ones that was not included in the domain, the answer you get here, this is where the domain starts. Okay, so when we write the domain, we start with this number. Since I have an equal sign, I'm going to use a bracket. So I'm going to go from -3 to positive infinity. So if you're looking at a number line, here is -3. And so we're starting here, going all the way over here. And then the last one, find the domain. So do we have a fraction? Yes. So we set the denominator equal to 0. Solve for x. So we say that 7 and -7 is not included in domain. So fractions, the answer you get is not included. Square roots, the answer you get is where you begin. So here I have this number line. So we're saying that we can use everything except for 7 and -7. So we can use all of these values. So my domain would be -infinity. But when we get to -7, we cannot use it. So I'm going to have -7 here with a parentheses, union. Then I'm going to start at -7 again. And I'm going to use all of these numbers up to the number 7. Union. But then I start at 7 again. Remember, 7 is not used. That's why we use a parentheses. And then you start from 8 to, from 7 to infinity. So throughout the semester, we'll be